Okay, welcome everybody to physics. We're talking about tension in a static situation. So static means it's not moving. So this would be like hanging signs or hanging, eaves off the edge of a building. This would be part of what we need to do for that. Okay, so we'll start with this one right here. We've got a ball hanging, 10-kilogram ball hanging from a ceiling. What is the tension? We'll call this T1. Okay? Very good. That is right. 100 newtons. So we know the force of gravity here is 100 newtons. And since this thing is static, that means there's no acceleration. Well, static means there's no movement, which by default there's no acceleration. It means that there must be the same force in the opposite direction. So tension is 100 newtons. Okay? So you can see that 100 or T1 is equal to the force of gravity, or 100 is equal to 100. But the question is here, I thought vectors had direction. They do, right? And these are both vectors. So can somebody tell me how the direction is indicated here? Because to me it looks like these are both positive numbers. Thank you very much, Lane. So the whole indication, these are both positive numbers. The way this sits, right? This is a positive number, that's a positive number. But if we would get them on both on the same side, you know, like so, I'm going to take this formula here. If I got T1 to the other side, then I would have to subtract T1 from both sides, right? So 0 would equal force of gravity minus T1. And that is where our indication of the direction is when they're both on the same side. So if you're talking vector stuff, and you would have two numbers on the opposite side of the equals, and they're both positive, then you should know that they're actually opposite in direction. And so if you look at it from the standpoint of the summation of forces, in this case must be 0, because it's not moving. The summation of forces is force of gravity plus T1. That is the actual summation because it's an addition thing, right? So once we put in our signs, if we say force of gravity is positive, then T1 must be negative if it's in the opposite direction. Okay? So I'm going to go through and write a lot of equations today, having one side equal to the other, but you have to know that they're opposite in direction and be okay with it. So make sure you understand what we just talked about here. Any questions about that? Okay, so now we have the same 10-kilogram mass. And I'm going to say that these angles are the same, and I'm going to say that they're equal to 30 degrees. Okay. So I'm going to call this T1 and this one T2. And just the first thing you always know for sure is, you know, there would be no tension if there's no force of gravity. Does that make sense? So that force of gravity is 100 newtons. Okay. Now the question is, what is picking up that 100 newtons? Is it full T1 and T2? Or what part of T1 and T2 is going to be picking this up? The Y part, right? So if I draw in my parts, now that, for example, let's just take a quick look at this piece and this piece. Should they be equal to each other in length? Yeah, because if they weren't, then there would be an acceleration in either direction. We know that's not happening. So these two things have to be equal to each other. So if I wanted to, I could write that in as they're equal to each other. I will have to later. Let's see if I have to for this one. Okay, then we have the y parts. Okay, how can we define these y parts mathematically? Well, first of all, you have to realize that this is 30 degrees here too, right? Because there's some geometry rule or postulate or something that says alternate interior angles are equal. Do you agree? Okay. So I can define this side right here as the sine of 30 T2. I can define this side here as cosine of 30 T2. And that's probably the first thing you're going to want to do with all my problems, is just define these sides and write it down. This one is the cosine of 30 T1. And this is the sine of 30 T1. Okay, you agree with that? Okay, so now we can work with this. So now we have to write some definite or some equations. So we know that 100 newtons here, 100 newtons is equal to but opposite direction of what two parts are going to be equal to that? It's going to be the sine of 30 T1 plus the sine of 30 T2. Do you agree? Okay. And then we can also say that the cosine of 30 T1 is equal to the cosine of 30 T2. Right? Because those two x's are canceling each other out, otherwise it'd be accelerating. So now we can see that T1 is absolutely equal to T2. You solve for that, do you agree? So now you can put either one of these definitions, right? We could put T2 in for T1 over here, because we know they're the same. Which makes this then 100 is equal to 2 times the sine of 30 T2, which means T2 is equal to 100 newtons. By default, that equals T1 as well, because we can really just plug this back into this equation. So T1 equals T2 in this case. They both equal 100. Do you have any questions on that? Okay, so we're going to find that asymmetrical. Okay. So I guess the first thing I would do when I'm doing these is draw my x components, because I know those are equal to each other. And then my y components will fall in line according to that. So I'll just say that, this here is equal to this. And then my y's fall in line according to that. So does that make sense that the y on the right should be a lot bigger than the y on the left? Yeah, okay. So, and then of course, these angles, 60 and 30. So the next thing I do then is draw my numbers. So I'm going to call this one here cosine 30. Oh, I better label my t's, T1 and T2. T2 or T1. I'll call this cosine 60 T2. I'll call this sine 60 T2. And I'll call this sine of 30 T1. So now I have all my little numbers that I need to put into my formulas, with the exception of this, which is 100 newtons. Right? Okay, so now I'm just going to start out with I guess I can do my cosine stuff first. So the cosine of T1 equals the cosine, oh, sorry. I did that wrong. The cosine 30 T1 equals cosine 60 T2. Okay, so then T1 is equal to the cosine of 60 divided by the cosine of 30 T2. Can someone give me that actual number? So divide cosine 60 divided by cosine 30 and give me what that actual number is, please. 0.5774 T2. So now I actually have a definition, and I kind of squiggle important things, because the box for me means that my final answer. A squiggle means, hey, I'm going to use this later, or I could use this. So that's the definition for T1 in terms of T2, right? So now we can write up an equation for the sine, or the vertical stuff, 100 newtons, then is equal to sine 30 T1 plus sine 60 T2. Okay, so now all you do is take this stuff here and plug it in instead of T1. Okay, so you did this in chemistry and stuff too already, right? So then 100 newtons equals the sine of 30 times 0.5774 T2 plus the sine of 60 T2. Now, at this point, I turn on everything into decimals. So the sine of 30 times 0.5774 is, that'd be what, 0.28, what is that? So that's 0.2887 T2 plus the sine of 60 times T2, so it's like what, 0.866? Is there one more decimal point, please? 0.866 T2. Now it's just a matter of solving for T2. Okay? So 100 still equals, what's 0.2887 plus 0.886? 1.155 T2. And so you divide both sides by 1.155. And we get finally our answer for T2 is 86.6 newtons. Okay? That's T2. Yay, we finally got our first answer. And that's the hardest one, right? Because we have this nice definition up here, that we can just take this number here, since it's equal to T2, and plug it in right there. So T1 then is equal to 0.5774 times 86.6, and we get, what? 50 exactly? Okay, so 50 newtons for T1. Do you have any questions about this process? Well, we'll give you some practice and see if you can apply this now. Okay? Enjoy.